Good day, students. You're welcome to Top Form Education Associates. We have today physics, and the topic we have now to discuss is heat energy. The materials we use in preparing this topic are Basic Physics for Senior Secondary Schools by P.N. Odume, New School Physics for Senior Secondary Schools by M.W. Anyokoha. At the end of this topic, we'll have the following objectives. At the end of this topic, the students should be able to, 1, explain temperature. These are the things you'll be able to explain after you finish studying this topic. Number 1, you explain temperature, explain the term expansion, change of state and vaporization, using kinetic molecular theory. Explain conduction, convection, and radiation in terms of kinetic molecular theory. Is that okay? These are some of the things we are able to achieve when we finish studying this topic. Now I want to look at the concept of heat and temperature. The concept of what? Heat and what? Temperature. Heat is a form of energy that brings about sensation. That is the feeling of warmth. When you are feeling warmth within yourself, the kind of energy or the form of energy that you're observing at that moment is known as what? Heat energy. So we'll say it's a form of energy that brings about sensation or the feeling of what? Warmth. When a hot object is placed in contact with a cold object, heat energy flows from the hot object to the what? Cold object. For instance, you have a sachet of hot water and a sachet of cold water. Bring them, two of them together, place them in contact with each other. You have it that heat energy flows from this hot sachet water to the what? Cold sachet water. So it does not flow from cold object to hot object, but from hot object to what? Cold object. A cold object does not warm a hot object, as I have said. So heat does not flow from cold objects towards hot objects. The SI unit of heat energy is joule. So the unit at which you use to identify heat energy is what? Joule. Heat energy is a derived quantity. It's not a fundamental what? Quantity, but a derived quantity. We have discussed about derived quantity and fundamental quantities. So we'll say that heat energy is a derived what? Quantity. Remember when we did fundamental and derived quantities, we found that energy is an example of what? A derived quantity. Now I want to look at temperature. What does temperature mean, or what is temperature? Temperature is a measure of the degree of hotness. The measure, the degree of hotness or coldness of a body. You're trying to measure how hot an object is or how cold an object what is. So what I'm measuring there is what? The temperature of that object. Is that okay? Temperature is also a measure of the average kinetic energy of the molecules of a substance. The average kinetic energy of the molecules of what? A substance. If you apply heat energy to a substance, for instance, water, you have it that the molecules will gain what? Kinetic energy. So we'll say it's the measure of the average kinetic energy of the molecules of what? A substance. And once they gain kinetic energy, you see the molecules moving about. And so what I'm measuring at that moment is known as what? Temperature. For instance, when water in a beaker is heated, as I've said, the average kinetic energy of its molecules increases. Thus, its temperature also increases. The SI unit of temperature is Kelvin or degree Celsius. We use capital K to represent Kelvin. Then we use degree C to represent degree what? Celsius. So these are the SI units. These are the units of what? Temperature, the SI units. Temperature is measured with an instrument called thermometer. Called what? Thermometer. This is a fundamental quantity. Just like we said that heat energy is a derived quantity, but temperature is what? A fundamental quantity. It does not depend on any other quantity for the definition, for its definition, but it's just there as a basic what? Quantity. So we say it is a fundamental quantity. Temperature also determines the direction of heat flow when two bodies are in contact with one another. For instance, I gave you an example. You have sachets, cold sachet water and hot sachet water. So this one is cold, the other one is hot. These are temperatures. Now, it determines the direction of heat flow. And I've told you that the heat flows from an object that is hot to an object that is what? Cold. So it flows from a hot temperature to what? A cold temperature. So temperature determines the direction of heat flow when two bodies are in what? Contact with one another. Distinction between heat energy and temperature. We want to see how we want to see the differences between heat energy and what? Temperature. It's been summarized in the table below. We have number one. Heat energy is a form of energy that brings about sensation of warmth. That is feeling of warmth. While temperature is a measure of the degree of hotness or coldness of a body. So we can use definition to differentiate both quantities. Number two, heat energy flows from hot objects to a cold what? Object when both objects are in contact with one another. So I've said it today. While temperature determines the direction of heat flow when two bodies are in contact with one another. So temperature determines the direction of the heat flow. While we say that the heat flows from hot object to a cold what? Object. Number three, the SI units of heat energy is what? Joule. While the SI unit of temperature is what? Kelvin or degree Celsius. So you can use the SI units to differentiate them also. Heat energy is a derived quantity, we have said it today, while temperature is a fundamental what? Quantity. Is that okay? Now the next subtopic, kinetic molecular theory explanation of temperature. Kinetic molecular theory explanation of what? Temperature. How do you use what is called kinetic molecular theory to explain what? Temperature. Now, the kinetic theory, molecular theory states that, when we talk about the theory itself, now it says that every substance is made up of tiny particles called what? Molecules. Every substance is made up of what? Tiny particles called what? Molecules. And these molecules of a substance are in constant random motion. These molecules of a substance are in constant random what? Motion. And so they possess kinetic energy. So this is just this kinetic molecular theory. So these molecules of a substance, they are in constant random what? Motion. And so they possess kinetic energy. If an addition of heat energy to a substance causes an increase in the average kinetic energy of its molecules. So when you add heat to a substance, the average kinetic energy of that substance, its temperature does what? Increases. Thereby increasing its what? Temperature. So when you add heat to a substance, its molecule will gain what? Kinetic energy. And once that happens, there will be increase in what? Temperature. Are you following it? On the other hand, removal of heat energy from a substance leads to a decrease in average kinetic energy of its what? Molecules. So if you reduce the heat now, energy applied to that object or that substance, the temperature does what? Decreases, because the kinetic energy is what? Reduced, because you have removed heat there. And so we'll say that this results in decrease in what? Temperature of the what? Substance. And so with this, we have seen that we can use this kinetic molecular theory to explain what? Temperature. In that if you add heat to a substance, for instance, you have water, you add heat to it, the molecules of that water, they will gain what? Heat energy. Do you understand? They will get heat energy, quite right. Then they will not be in motion, not about kinetic energy. So the kinetic energy now will increase, of these molecules will increase. And once they start moving about, because of addition of heat, you have increased the what? Temperature. But once you now remove the heat, what happens? The temperature will reduces. So with this, we have used this kinetic molecular theory of matter to explain what? Temperature. Thus, temperature is a measure of the average kinetic energy of the molecules of what? A body. Now, I want to look at effects of heat energy. What are the consequences of applying heat energy to an object? What are the effects? The effects of heat energy when added to an object are summarized below. It leads to 1. Change in temperature of the body. This can lead to change in temperature of the what? Body. Addition of heat to an object will cause the temperature of that object to rise. The addition of heat to an object will cause the temperature of that object to do what? Rise. Except at melting point of solids and boiling point of what? Liquids. At melting point of solids, we have that the temperature does not change. You have a constant temperature until the whole ice there melts. Then you cannot have change in what? Temperature. Now at the boiling point of liquid, once it gets to boiling point, no matter what you add, no matter the amount of heat you add to that liquid, the temperature cannot increase. For instance, we'll have it that the boiling point of water is 100 degrees Celsius. Once it gets to 100 degrees Celsius and you add more heat to it, the temperature does not do what? Change. Are you getting it? Does not change. So I said at this particular point, so it does not change. Instead, it will now turn towards vapor. So we'll say addition of heat to an object will cause the temperature of that object to rise, except at melting point of what? Solids and boiling point of liquid. So as said at these 2 points, temperature does not do what? Increase or rise. Number 2 is expansion of the body. Expansion is leads to what? Expansion of the what? Body. Addition of heat to an object leads to increase in the dimensions of the object. If you have it that that object expands, it's expansible, you have it that once you add heat to it, what happens? The dimensions will do what? Increase or expand. This can be in length, area, or volume of the object. So it can lead to increase in length, or increase in the area, that is length and the breadth, or the volume, meaning increase in both length, breadth, and what? The thickness, or we can say the height of that object. So once you apply heat to such object, it leads to what? Increase in the what? Dimensions of the object. Now number 3, it leads to thermionic emission. Thermionic what? Emission. Addition of heat to a metal may result in the emission of electrons from the surface of a heated metal. For instance, you have zinc. When you newly bought, you see it's shiny, but with time it will start rotting. What happens? There is heat from the sun incidentating on it. So addition of heat, once it incidentates on it, on such metals, sometimes electrons are emitted. And so we have it, the addition of heat to a metal may result in the emission of electrons from the surface of a heated what? Metal. Number 4, change in the physical properties of a body. It can lead to change in the physical properties of a body. Addition of heat to a body may cause changes in elasticity, density, color, electrical resistance of an object. For instance, you have an elastic material. If you put heat to it, what happens? It will lose what? Is elasticity. Is it not true? And so we have that it leads to change in physical world properties like elasticity. You have density of the object, mass over volume of the object. If you add heat to it, then it will do what? Change. The mass and the volume will not, yes, the volume will not remain the same. And so for that reason, the density would not be the same. Color, some clothes, when you bring them outside under the sun for a long time, the color changes. So change in addition of heat brings about what? Change in physical properties of what? A body. Number 5, it leads to change of state of what? A body. Change of what? State of what? A body. Change of state of a body occurs when a solid changes to a liquid and liquid changes to gas, or the reverse. We don't have 3 states of matter. We have solid, liquid, and what? Gases. So when you add heat to a solid material, it can change to a liquid, and from liquid to what? Gaseous states. This can easily be achieved by heating or cooling the substance. So either if you cool the liquid, it can turn to what? Solid. Then if you heat the solid, it can turn to what? Liquid. As we're going to see the example. The simplest substance to use in studying change of state is what? Water. A change from solid, example, ice block, to liquid is called fusion. When you're changing ice block to liquid, it is now melting. We call that process what? Fusion or melting. So the constant temperature at which this takes place is called melting point. I get things. The constant temperature. At this particular temperature, when the ice is melting, until the whole ice block there, that container melts, the temperature will not change. So we say the constant temperature at which this takes place is called what? Melting point. Also, the constant temperature at which a liquid changes to a solid. A liquid changes to what? Solid is known as what? Freezing point of what? A liquid. So at this point also we have also constant what? Temperature. It is now cooling. From cooling now it now turns to liquid. Means it's now freezing at this point. We call this freezing point of what? A liquid. Also a change of state from liquid to gas. A change of state from liquid to gas is called what? Vaporization. Now you are boiling water and the water has now reached boiling point, 100 degrees Celsius, for instance, now out of water. So at the same portion, that process of boiling now, of changing from liquid to gas, is known as what? Vaporization. And the constant temperature at which this takes place is called what? Boiling point. We say constant temperature. I've told you, if you have it that you are boiling water and it has reached 100 degrees Celsius, when you measure it with a thermometer, at that point, the temperature does not change. It has not reached 101 degrees Celsius for the first time. The boiling point of water. So it's also a constant temperature. So instead of it to increase the temperature, rather the water will now change from liquid state to what? Gaseous state. So the constant temperature at which this takes place is called what? Boiling point. Is that clear? The next is expansion. So after studying this topic, you're able to explain the term what? Expansion. Expansion means increase in the size of an object. Increase in the size of what? An object due to the application of heat. You're increasing the size either in length, breadth, or what? In height. So we'll have expansion means increase in size of an object due to the application of what? Heat. When heat is applied to most solids and liquids, when it is applied to most solids and liquids, they expand. So if you apply heat to liquids, some solids and some liquids, they do what? Expand. They also contract when cooled. Expansion of an object can be in length, as I've said. If it is in length, it is called linear expansion. It can be in area, meaning both length and breadth. Meaning we call that superficial expansion. or it can be in volume, involving the length, the breadth, and the thickness of that, or we can say the height of that object. We call it cubic word expansion.